Venus melts the metal lead. It crushes solid steel like an empty soda can. And almost every machine humanity has ever dropped onto its surface has died within minutes to a couple of hours. Most built to last barely 30 minutes, and many not even surviving a full hour. After more than 60 years of trying, the all-time survival record on the surface still sits at just over 2 hours. This is the planet next door, the one we call Earth's twin. And it is, without exaggeration, the most hostile surface in the entire solar system. Here's the strange part. From space, Venus looks gentle. It is almost exactly Earth's size, made of the same kind of rock, formed in the same neighborhood from the same material. For most of the 20th century, scientists and science fiction writers were convinced that under those bright, swirling clouds sat a warm, wet world. Maybe jungles, maybe oceans, maybe even life. They could not see the surface. The cloud deck is total, wrapping the whole planet, so they were free to imagine a tropical paradise. They could not have been more wrong. The first hint of the truth came when probes started measuring the air. The atmosphere of Venus is roughly 96% carbon dioxide, and there is a staggering amount of it. The pressure at the surface is about 92 times what you feel at sea level on Earth. To put that into something you can actually feel, it is the same crushing weight you would experience nearly 1 kilometer beneath the ocean. Standing on Venus, that air would not feel like air at all. Down at the surface, the carbon dioxide is squeezed so hard it stops behaving like a normal gas and becomes a supercritical fluid, something between a liquid and a gas, that flows around you like a hot Hev soup. Then there is the heat. The surface of Venus sits at around 465 degrees Celsius, which is roughly 870 degrees Fahrenheit. That is hot enough to melt lead, zinc, and tin. And here is the detail that genuinely broke scientists' brains. Venus is hotter than Mercury, even though Mercury sits right beside the Sun, and Venus orbits nearly twice as far away. The planet closer to the fire is the cooler one. The reason is a runaway greenhouse effect, and it is the single most important thing to understand about this world. All that carbon dioxide works like a one-way blanket. Sunlight filters down through the clouds and warms the ground. The ground tries to radiate that heat back out as infrared, but the thick carbon dioxide traps it, throws it back down, and the surface just keeps climbing. On Earth, our oceans and rocks pull carbon dioxide out of the air and lock it away, keeping the balance. On Venus, that safety valve broke long ago. Whatever water the planet may once have had boiled off and escaped into space. The carbon dioxide piled up with nowhere to go, and the temperature ran away until the whole planet became an oven that never cools down, not even on the night side. And as if heat and pressure were not enough, Venus drapes itself in thick clouds of sulfuric acid. Not water clouds, acid. The kind that eats through most metals and dissolves ordinary spacecraft fabric. So any machine you send has to survive being crushed, cooked, and corroded, all at the same time. Knowing all of that, the fact that anyone ever landed on Venus at all is one of the most underrated achievements in the history of engineering. And it was the Soviet Union that decided to try, over and over, with a program called Venera, Russian for Venus. The early attempts were brutal lessons. Venera 3 reached the planet in 1966 and became the first human-made object to strike another world. But its systems had already failed on the way in, so it hit the surface silent and sent back nothing. Venera 4, in 1967, sent back the first real data from inside the atmosphere before the pressure squeezed it flat, well before it ever reached the ground. Venera 5 and Venera 6 pushed deeper in 1969 and were crushed too. Each failure taught the engineers the same grim truth. Venus was far worse than anyone had modeled, and their spacecraft were being flattened like paper long before they could land. So they massively overbuilt the next one. Venera 7 was essentially a titanium sphere about 1 meter across, built more like a deep-sea submarine than a spacecraft, with thick insulation packed inside. And here's the clever, almost desperate trick. Before it entered the atmosphere, the team chilled the entire interior down to well below freezing. The logic was simple. Start as cold as possible, so it takes longer for the Venusian heat to seep in and cook the electronics. On December 15th, 1970, Venera 7 went in. Its parachute tore during the descent, and the probe slammed into the surface in something close to a free fall, then toppled over onto its side. From the control room, it looked like just another failure. Faint noise, and nothing more. But when engineers went back and dug through the recordings, they found it. 23 minutes of weak signal coming from the surface of another planet. The antenna was pointed the wrong way. The signal was barely there, but it was real. Venera 7 had become the first spacecraft in history to land on another world and transmit data home. Its instruments reported a surface temperature around 465 degrees Celsius. The science fiction Venus, the jungle paradise, was officially dead. From there, the Soviets kept refining the design. Venera 9, in 1975, did something that still feels impossible. It sent back the first photograph ever taken from the surface of another planet. To pull it off, engineers built a camera that peered out through a thick quartz window using a periscope, capturing a black and white panorama of cracked, rocky ground before the heat killed the lander 53 minutes later. Then they went further still. Venera 11 lasted 95 minutes. Venera 12 lasted 110 minutes. And then came the masterpiece. On March 1st, 1982, Venera 13 touched down on a flat plain in a region called Phoebe Regio. Its official design life, the time the engineers genuinely expected it to last, was just 32 minutes. Instead, it kept working and working, transmitting through heat and pressure that should have destroyed it several times over. By the time it finally went silent, it had survived 127 minutes. Over 2 hours. In that window, it captured the first color photographs ever taken on Venus, revealing a bleak orange landscape of flat rock under a dim, rust-colored sky. That color comes from the thick atmosphere filtering out blue light before it ever reaches the ground. The lander even carried a microphone and became the first probe to record sound on another world. That 2-hour, 7-minute survival record has never been beaten. Its identical twin, Venera 14, landing just days later, managed only 57 minutes. Now think about what that actually means. The most advanced Venus landers ever flown. The absolute peak of decades of effort, topped out at roughly 2 hours before the planet erased them. And here is the part that should genuinely surprise you. No spacecraft has landed on the surface of Venus since the mid-1980s. Not one. For all our progress, rovers driving across Mars for years on end, probes touching down on comets and asteroids, the surface of our closest planetary neighbor has stayed off limits for 40 years. Because nobody has solved the basic problem the Soviets ran into. Normal electronics simply cannot run at 465 degrees. They cook. So the only option has been the Venera trick: refrigerate a sealed box and race the clock. And the clock always wins. But that may finally be changing. At NASA's Glenn Research Center, engineers built circuits out of silicon carbide instead of ordinary silicon, a material that does not break down in extreme heat. They drop those chips into a chamber that recreates the full surface of Venus, the heat, the crushing pressure, the toxic chemistry, with no cooling and no protective casing at all. Ordinary electronics last minutes in there. These ran for 521 hours, about 3 weeks, and were still working when the test was switched off. That's more than 100 times longer than any Venus lander in history ever managed. That breakthrough is opening the door to a brand new wave of missions. NASA's Da Vinci probe is set to plunge through the Venusian atmosphere in the early 2030s, dropping from above the clouds all the way to the surface, while sampling the air the entire way down. Alongside it, NASA's Veritas orbiter and Europe's Envision will map the planet in unprecedented detail from above, all chasing the same haunting question at the heart of this story. How did a world so much like Earth turn into a furnace? And could it ever happen here? Because that is the real reason Venus matters. It is not just a hostile rock floating next door. It is a warning. A planet that started out as Earth's near-perfect twin, and through a runaway greenhouse effect became the deadliest surface in the solar system. A place that destroys the toughest machines we can build in the time it takes to watch a movie. The Soviet landers that reached it are still down there right now, slowly being crushed and dissolved into the surface of a world we still barely understand.